Okay, this is your video for 8.1. 8.1 is sometimes a tricky concept, and it's not really the concept itself. It's that once you get used to it, it's pretty easy, but then we throw in a lot of algebra, which is why we spent a lot of time in Chapter 7 doing algebraic proportions, which is why we spent time reviewing how to factor, because all of those things come back up in 8.1. So we're actually going to spend 2 days on this so that you can have it down really well. All right, the altitude just meaning height, of a hypotenuse of a right triangle forms two triangles that are similar to each other and the original triangle. So basically, we're going to have three similar triangles. So you can kind of see right here, you have a baby one over here, you have a medium one over there, and then the entire triangle forms a third. So pause right here and redraw these as three separate triangles. You're going to want to make them all face the same way so that you can see, oh, that was not very good, so that you can see them all being similar. Ready, set, go. Okay, here's what they look like. So I put them small, medium, large, and then it's easiest if you line up, you know, the right angle for the small and the medium is Z, and then the right angle for the large one is W, and then I just said, okay, to go across the short side would be to go to V, and then the other one would be W. For this one, the short side is W, and the long side is U, long leg. And then for the big one, the right angle is W, the short leg is to V, and the long leg is to U. So these are similar triangles, which means we can set up proportions and do everything we need to do for similar triangles. But is this how you would have picked to set up the proportion? Probably not. Okay, so these similar triangles can be used to set up proportions to solve for missing side lengths. Just like we did all in Chapter 7, you just now have to rearrange the triangles to set up the proportions, whereas last chapter they were just given to you. All right, there are two proportions that will be helpful. We call them Paap and Hllp because, you know, that's just a little acronym that'll help you remember them. So we're going to start with Paap. So Paap stands for part to altitude equals altitude to part. So when you set it up, it looks like this. Part over altitude equals altitude over part. Okay? You use Paap when you have the altitude or you are looking for it. Okay, so altitude, remember, is just the little height going from top to bottom. So the reason you say that you use Paap when you have or are looking for the altitude is because this whole thing is centered around the altitude, your whole proportion. So it's the driving force behind Paap is your altitude. All right, so I'm going to zoom in here and look at this example. Draw this example on there so we can go through it. So we're going to go through this diagram tomorrow in class, so you don't have to get all of this today. You just have to get a general understanding. So your parts are the hypotenuse. When you draw in your altitude, it cuts your hypotenuse into two parts. So that's why we say parts. So this is a part, and this is a part, and then this is the altitude right there. So this one is set up for Paap because I am looking for the altitude, and I have the parts. So let's set up a proportion. Part over altitude equals altitude over part. And this altitude, these catty corner ones here, will always be the same. Every time they have to be the same. These parts are different in this case because there are two different lengths right here. One's 5 and one's 9. So you use each one of them once. You can think about Paap as like you're kind of making a V. Part to altitude, altitude to part. So you're making like a little V right there. Okay, and then once you have the proportion, this is what we spent all last chapter doing. You're just going to cross multiply. X squared equals to 45, and then you're going to solve. So remember, we spent all that time doing radicals also for this very reason, because we're going to need them again. So 45 breaks down to 3 on the square root of 5. Make sure you're just being smart when you do these. Look at these numbers. These are what I multiplied together to get 45. So looky there. There's a perfect square. Square root of 9 is 3. 5 doesn't have a perfect square, so he stayed inside. All right, let's come over here and do another one. Looky there, another radical. Okay, in this case, I have the altitude and I am looking for a part, but still the same thing. This is a part, this is the altitude, this is the other part. So I can set this at part over altitude equals altitude over part. Most people don't have a single problem with remembering Paap and Hllp and setting up their proportions. Why this lesson is so confusing is because we have a lack of algebra skills in our radicals and in our quadratics. So that's what we're really going to need to focus on here and make sure that our algebra doesn't cause us to have low grades. All right, so cross multiply, 7x is equal to, remember when you're multiplying radicals, it's just outside with outside, inside with inside. So multiply your like terms together. Okay, so 3 times 3 is 9. Square root of 2 times square root of 2, I'll do this the long way, is the square root of 4. Which square root of 4 is just 2. Remember, anytime you multiply a square root by itself, basically the square root goes away. So 7x is equal to 18. So x is equal to 18 over 7. Just like that. Good. Okay, so the other proportion is Hllp, and it stands for hypotenuse to leg, leg to part. So hypotenuse, the whole long side of the big triangle, over leg, one of the legs of the big triangle, equals leg over part. So again, just like in Paap, this catty corner right here, this leg, will be the same leg. That number should always match. So even though the right triangle has two different legs, this is a leg and this is a leg, we don't, and this guy has a part and this guy has a part, let's call this leg 1 and his part 1, this is leg 2 and his part 2. You can't cross over legs. You got to stay on one side of the triangle or the other. You don't mix and match. So that's what this little note says. The leg and the part have to come from the same side of the triangle. So if I'm trying to find this leg, then I use this part. Or vice versa. If the problem gave me this part, then I will be solving for this leg. So you have to stay on the same side of the triangle. No mixy-matchy. You use Hllp when you have a leg or you're looking for it. So just like Paap was centered around altitude, so we were looking for the altitude or we had the altitude, same thing here. This is centered around leg, so we know we need to use Hllp when we have a leg or we're looking for it. All right, let's dive in. Okay, so here I can tell, look, I'm looking for a leg, so I know I will need to use Hllp. Okay, so let's label these parts. So again, remember these are your parts, and this is your leg. But when I do Hllp, hypotenuse over leg equals leg over part. Sorry, my app did something funny. This picture happened to give me both parts, so all I really need to do to get the hypotenuse is just put them together, and then I have the hypotenuse. Okay, so the hypotenuse is 10 because it's all the way across over the leg equals the leg over his part. So since I'm trying to find the leg on the left side, I need to use the part on the left side. So I would use the 4. If you use the 6, your whole proportion would be wrong. So there we go, set up our proportion. So now we cross multiply, x squared equals 40. So x is equal to 2 on the square root of 10. Again, look what you have here. 4 is a perfect square. Square root of 4 is 2. 10 doesn't break down by itself, so then it just stays. Okay, this triangle is turned sideways, but it's still the same thing. It's a right triangle with an altitude drawn in there. And look here, I have the leg, so I know I'm going to need to use Hllp. Okay, so again, they didn't give me the hypotenuse, but they gave me the two parts. So if this part's x and this part's 3, then when I add them together, I just have x plus 3. So you can see the algebra is kind of stepping up a notch here. So because now I have an expression for the hypotenuse instead of just a variable, instead of just an integer or a radical or something easy like that. So I have hypotenuse to leg equals leg to part. So remember, I have to use the part on the same leg. So I want to use the 3, not the x. Okay, so here we go. Don't forget to distribute. So I have 3x plus 9 is equal to 2 times 2 is 4. Square root of 3 times square root of 3 is just 3. Okay. All that for 1. Good. X is equal to 1. And you remember, you should never miss an algebra problem because you can always go and plug it back in and make sure that it works. Okay. Okay, let's do a couple of word problems. And normally we think that the word problems are harder, but actually in Paap and Hllp they're easier because usually you don't have too many algebraic expressions and radicals and all that kind of stuff. So you'll actually probably, for once in your life, like a word problem. All right, to estimate the height of a Douglas fir, Jan positions herself so that her lines of sight to the top and bottom of the tree form a 90-degree angle. So basically they just told us that this is a right angle. Because remember, Paap and Hllp only works with right triangles. So if this weren't a right triangle, we wouldn't be able to do anything. All right, her eyes are about 1.6 meters above the ground, so that's this distance, which is apart. And she is standing 7.8 meters from the tree. So in this case, that's actually the altitude. What is the height of the tree to the nearest meter? So they're actually asking us for the entire height of the tree, which is the hypotenuse. So that kind of makes you think, okay, well, hypotenuse, let's do Hllp. But to do Hllp, remember, you need a leg, and we don't have a leg here. We have a part, and we have an altitude. So actually what we're going to do is we're going to do Paap to find this other part right here. Let's call him Y. And then I'll have both the parts and I can just add them together. So let's say 1.6 over 7.8 equals 7.8 over Y. So let's see here. 7.8 times 7.8 is 60.84. Oopsies. Oh, sorry. So then when I divide by 1.6, I get that Y is 38.025. So remember, Y is just this part right here at 38.025, but I'm trying to estimate the whole height of the tree, so I need to add back on that 1.6. So that gives me 39.625. And the problem said to the nearest meter, so I would answer 40 meters. Okay, very good. Same sort of issue over here. A surveyor positions himself so that his line of sight to the top of the cliff and his line of sight to the bottom is shown below. What is the height of the cliff to the nearest feet? So why don't y'all pause right here and try this one just like the tree and see if you can get it on your own. Okay, so I did just the same thing. I did Paap. So I set up 5.5 over 28 equals 28 over Y, which gave me a value of Y. So this top part at 142.5 almost. So then when I add back on the bottom part down there, I get 148. So rounded to the nearest is 148 feet. Okay, you really need to understand, we're going to go over this, we're going to make a little diagram for you to use in class on Tuesday, but the examples that we're going to do from here on out have a lot more algebra, they have quadratics in it, radicals, fractions, all that kind of stuff, so it's super important that you understand the proportions of Paap and Hllp really well so that when we start throwing in higher level algebra, that you don't kind of sink. All right, see ya.